Hello everyone, welcome to another kinetic tutoring video. Today we're looking at a differential equation that is given to us for a oscillating spring, and it wants us to find the period of the oscillating mass attached to the spring. So let's just get right into the problem. The prompt reads, a mass oscillating on a spring has a differential equation of motion, 2 kilograms d2x dt squared is equal to negative 0.5 kilograms per second squared x. What is the period in seconds of the oscillating mass? Alright, so the first step we're going to want to take is to rewrite the equation but without the units, so it looks a little more simple. We'll have 2 kilograms, you can just write as 2 d2x over dt squared is equal to negative 0.5 x, and from here we know that the d2x dt squared is just the second derivative of the position function, which will give us acceleration. So then here we have 2a is equal to negative 0.5 x, and the last step we're going to take to find our acceleration is to divide both sides by 2, and we'll get that negative 0.25 x is our acceleration. And now, if we take a look at our spring equation, or rather our displacement equation for a simple harmonic motion of a spring, we'll see that the displacement of a spring is going to be the amplitude of its displacement times sine or cosine of omega t. We'll use sine in this case, but you'll see in a moment that it doesn't matter. So let's find acceleration in terms of t. And what we're going to want to do to get that is take two derivatives of this function. So the first derivative will give us v of t is equal to a cosine omega t times the derivative of the inside, which is going to give us omega. The second derivative is going to be our acceleration, which will be negative a sine omega t times the derivative of the inside again, which will give us omega squared. And from here we see that there's a sine omega t down here and up here. So we can just replace this omega t down here with displacement. So we'll get that our acceleration in terms of time is simply negative displacement times omega squared. And from here we see that we have pretty similar formulas when we took a look at these two. So let's set them equal to each other. Get that negative omega squared x is equal to negative 0.25 x. We can cancel out the x, cancel out the negative, and we'll get that omega squared is equal to 0.25. Now let's solve for omega. We know that 0.25 is 1/4, so omega is going to give us square root of 1/4, and the square root of 1/4 is simply 1/2. And here's the final step. We know that our period is 2 pi over omega, and this is derived from omega is 2 pi over t. All we did was swap these two, and so let's plug in our omega of 1/2. Dividing by 1/2 is the same as multiplying by 2, so t is equal to 2 times 2 pi, which will give us a period of 4 pi or 12.6 seconds. I hope this helped, and make sure to tune in later for more physics tutorials.